In the previous video, I briefly explained to you what a limit is. It doesn't matter if you don't fully understand the previous video. Now I'm just going to bombard you with lots and lots of examples. So here, let's say you've got a function here, f of x here equals sine of x. So here, the limit, the limit of sine of x here as x heads towards pi over 2. So basically, pi over 2 is right here. So basically, the limit, well, as x heads towards pi over 2, it means you're moving you're moving from the left hand side. You're moving towards well, x towards pi over 2. So you're moving in this direction, which happens to be it's heading towards 1. And then also you got to move from the right hand side as well. So move from the right hand side. So here, here, and you're also heading towards 1. So the limit here is 1. So for you to have a limit at this point here, you've got to head towards this point here from the left hand side and from the right hand side. And if they meet in the same place, then you have yourself a limit. Okay, if you happen to have a function where this one heads towards 1 and then this one here heads towards something else, here you don't have a limit here. But because the left hand side is equal to the, well, as you head towards from the right hand side, because they meet at the same limit, then the limit here is 1. Okay, here's another example. Suppose you have a function here, f of x equals this thing here. Okay, so here it's well, the limit here, hang on. So here you've got the function here. The limit as x tends towards infinity. Now tends towards infinity, it means as x moves towards infinity here, you cannot head from the right hand side. You can only head towards infinity, positive infinity, from the left hand side. There's only one direction. So here you don't need to worry about heading towards from the right direction. So here, as x tends towards infinity, the limit will be 0. So here the limit will be 0. Okay. Now here the limit as x tends towards 0. So that means you've got to move from the left hand side here. Okay. So here, by the way, this point here is 1 because if you have any number here to the power of 0, it will be 1 for my indices. If you don't understand this bit, watch a video on the indices. Anything to the power of 0 would be 1. So this point here is 1. So here the limit as x tends towards 0, that means it's heading towards 0 here. Don't forget x equals 0 is here. That's what it means. X heading towards 0. So here it's heading towards 0. It's heading towards the number 1. Now you've got to look from the right hand side as well. So now from the right hand side it's also heading towards 1. So because the left hand side is the same as the right hand side, then you have yourself a limit. So it's 1. So suppose you had something like this that heads towards a different location here. Then in this case, there would not be a limit. But because the left hand side is coming from the negative side, is the same as a positive side, you have yourself a limit here because the left hand side is heading towards the same place as the right hand side. So the limit exists. Okay, here's another example. Suppose you've got yourself a negative quadratic here. Now, as x tends towards 4, so from the left hand side it's heading towards. So this point here is 4, by the way. Okay, this point here is 4. So it's heading towards you see, it's heading towards a limit here, and from the right hand side it's also heading towards the same point. Well, whatever this point here is your limit. So in this case, you can simply put the 4 into here. Okay, so this bit here will be will be positive 1. 1 squared here will be 1, and then negative 1 here. So well, and then negative 1 plus 9, it will be positive 8. So in this case here, the limit as x tends towards 4, so that means you're heading towards here. This point here is 8. Okay, it's heading towards 8. So for you to interpret this, you've got yourself a function here. Now, x tends towards 4. So let's say this here is 4. So that means it's heading towards 4. So as x heads towards 4 here, this point here is 8. Okay, 8 here, 8. And then you've got to consider the right hand side as well. So it's heading towards 8. Now, because the left hand side is the same as the right hand side, then the limit exists. Okay, and then soon we will develop theories where you can visualize it as like this. So here you've got your function. Break the function up into two different components. Now from here we can do something like this. Hang on, limit as x tends to 4 of this part. Doesn't matter if you don't understand this bit. I'm just saying what you can do in the future. Okay, this here, the limit of this equal plus the limit of 9 as x tends towards 4. Now this answer here will be the same as this answer here. Okay, well it doesn't matter if you don't understand this point here, but my point is that when you have a complicated function here, you can break up the two, and then the limit of this part plus the limit of this part. Again, you don't understand it. It doesn't matter if you don't understand it. Okay, here's another example. Suppose you have a function here of f of x equals 7. So it's just a straight horizontal line. Now the limit at a, so the limit of I should have a 7 in here. Hang on. The limit of 7. So this is our function here. That normally goes in here. Okay. So the limit of this as x tends to a. Let's say this is a here. So x tends to a. So you're heading from the left hand side to here. It will head towards 7. And then consider from the right hand side. It's heading towards the same point. So the limit of 7 as x tends to a will be 7. In fact, as x tends to b, it will be 7. As x tends to c, wherever c is over here, it will be 7. If say you've got a limit of, let's say this 7 here. Now as x tends to infinity, it will still be 7, because if you head towards infinity, it will, well as x tends towards infinity, the limit will be 7. Okay, even if and here, even if you have negative infinity here, so x tends towards negative infinity, the limit will be 7 also. Okay.